Hello, Vikings! Today we're going to be looking at counting atoms. Our objective today, we're eventually later in the week going to be learning how to balance chemical equations. And to do so, we've got to be able to take a look at the equations and count the atoms that are in some of the chemical formulas in them. So just as a reminder, let's go forward. This is a chemical equation, and if you take a look at it, you can see that you have copper, Cu, and then you have a plus sign, so you're adding something to it. In this case, it's silver nitrate, and you're producing a copper nitrate and silver. So this is an equation, and you'll see that we have all kinds of elements happening. We also have numbers in the front of the compounds. We call these coefficients. We also have numbers that are a little bit below the elements, and we call these subscripts. These are important to know because when we are balancing equations, knowing which we're working with will allow us to be able to count atoms correctly and to balance the chemical equations correctly. Okay. So when we just looked at that big, long chemical reaction, this was just one little portion of it, silver nitrate. And we would call this a chemical formula. So I just took one piece out of that puzzle. And that's all we're doing today, is just looking at little simple chemical formulas and counting how many atoms that we have. In this case, we have silver nitrate, and there's a 2 in front of the silver. And we're going to call that the coefficient, okay? We also have another number in this chemical formula. We have the 3, and it is lower than the element oxygen, so we call it a subscript. What we find is that when we are talking about coefficients, the number applies to all the elements that are after the number. So here when we're looking at the 2 applies to the silver, but the 2 also applies to the nitrate, or the nitrogen and the oxygen. When we look at subscripts, however, subscripts only apply to the element that's directly in front. Occasionally we'll have a subscript that is outside of a parentheses, and if it's outside of a parentheses, then it applies to everything in the parentheses. So very important to get a handle on the difference between what a coefficient is, that's the big number out front, and a subscript, that's the little number below. Okay, so we're going to practice counting atoms. First, we're going to look at CO2, or carbon dioxide. And when we look at this simple chemical formula, we notice that all that is present is a subscript, the 2. Okay, so that's the only number we're looking at. So when it asked us how many atoms of carbon do we have, we see that we've just got 1 carbon, okay, because the 2 does not apply to the carbon. When we get to oxygen, however, we see this 2 subscript, and that means there are 2 oxygen atoms. So if we're asked how many carbon, we know we have 1. How many oxygen, we know we have 2. But what if someone asked you how many atoms are in this formula? Well, we would just add how many carbon and oxygen we have together. And in this case, the total amount of atoms would be 3 in that whole complete formula. So this is counting the atoms in carbon dioxide. We're only looking at a subscript. Next, we are going to look at a chemical formula with a coefficient. And here we have lithium chloride, and there is a 4 out in front. So I mentioned earlier that when we have a 4 applies to all the elements after the number when it's a coefficient. So how many atoms of lithium do we have? Well, there's a 4 in front, so there are 4. Okay, and don't let this trip you up, but when you get to the chlorine, we also have 4 because that 4 applies because it's out in front of the whole chemical formula. So we have 4 chlorine. So our total atoms for this formula would be 8 because we have 4 lithium and 4 chlorine. Now I'm going to pull up my pen because for some of you who are a little bit more visual, let me pull up Sketchbook. Come on. Okay. Let's see. All right. So if we have 4 lithium chlorides, I'm just going to write them out here. LiCl, there's 1. LiCl, there's 2. There's 3. And there's 4. So when we say we have 4 lithium chlorides, this is what we're saying. But it's a lot easier just to put a 4 in front. Okay? And if you were to count these, and let me get a different color. I'll get a red. You can see that we have 1, 2, 3, 4 lithium. Okay, we'll pick a green, and we have 1, 2, 3, 4 chlorine. So that's what it means when you have that 4 out in front. 4 of these lithium chloride compounds. And if you list them up, you can see where we get the 4s from. So if you're more visual, that may help. Let me go ahead and expand this again. And we have looked at a subscript. We've looked at a coefficient. Now let's put them together. Okay, so now we have calcium chloride, but we've got a coefficient out in front that says 2 calcium chloride. So how many atoms of calcium? So if we look out front, we have a 2 out front. So there's 2 there. And there are no subscripts that apply to calcium, so it would just be that 2. All right, so then we look at the chlorine. So we've got 2 numbers that apply to it. We have the subscript 2, which says we have 2, and then we've got that 2 out front. And what we're going to do is multiply them. 2 times 2, we have 4 chlorine atoms. So you just add these together, 2 calcium and 4 chlorines, and you'll find that you have a total of 6 atoms in this compound. So here we go. I'm going to get a new page. Let me get a new page over here. Okay, so just giving an example for the more visual learners, it says we have 2 calcium chlorides, so I'm just going to write those out. CaCl2, there's our first one, CaCl2. Okay, so this is our 2 calcium chlorides. So if we are counting them, we're counting how many calcium we have. Clearly 1 here, 2 here. Okay, and that's where we get our 2 from. So then if we're counting our chlorine, we see that we have 2 chlorine here and 2 here. So that's where we get our 4 from. So for those of you that helps visually, that's where we're getting them. Okay, so we put them together. There's only one other way that it can get more complex, and that's through adding parentheses. So this is as hard as it can get. We've got subscript, we've got coefficient, and we've got parentheses. And this, we're going to go through this step by step. The first element that we have in this chemical formula is calcium. So when we look at it, we see that there is no subscript that applies to calcium, but there is a coefficient of 2. So we have 2 atoms of calcium. Then we look at oxygen. Now we have the 2 out front, so we know the coefficient applies to oxygen, but when we look at this 2 down here, it applies to the whole parentheses around the OH. So when you have 2 OHs, okay, and let me get a new page to show you. Okay, so this is part of our formula. And what we're saying is that we have 2 OHs. Okay, which means if you add them up, you have 2 oxygen and you have 2 hydrogen. Okay, so let's go back over here. So we've got 2 oxygen here and a 2 here, so we're going to multiply, that would be 4. Okay, we're going to do the same with the hydrogen because we know that we've got 2 OHs, so there are 2 hydrogen. 2 times 2 is 4. So 4 plus 4 plus 2, we've got 10 atoms in this compound. 2 calcium, 4 oxygen, and 4 hydrogen. So that's as difficult as it gets. Today, all that I ask is that you do a very short worksheet that I have and check your answers. You're going to have a formula or two with just coefficients, some with coefficients and subscripts, and a few with parentheses. So good luck, Vikings. I hope you have a fabulous day.